Let me present our next speaker. It's Joëlle. And I'm going the floor to Joëlle. She's a professor of the Department of Biology and Toxicology of the Uppsala city, professor of environmental toxicology. She got the title of professor at Max Planck University in Munich. And she also worked as a researcher at Karolinska University, also in Basel University in Switzerland. And since 2010, she has her own research group, which is focused on epigenetic group of the substances that destroy the brain. And she's also the head of huge interdisciplinary projects financed by European Union that favor the work, the prevention of the work with the EDC chemicals, endocrine disrupting chemicals, and how to prevent their effect. So, Joëlle, the floor is yours, and please share your presentation once you're ready.
Great. Thank you so much for inviting me. As Paulina already said, it is extremely special for us to talk to this audience today. And I will focus on children's health, as already was announced, and we'll start with a slide which probably is very familiar to you, why children are particularly sensitive, because of course during development there are these sensitive phases where different organs develop, and depending on which organ we look at, the sensitive phases are different and differently long. For example, the brain and the central nervous system start very early during fetal development and then go on until 25 years of age. So this is an extensive sensitive phase for example, exposures to chemicals. And another thing which you probably, most of you are familiar with, is that hormones are very important in driving these processes. And we know that in extreme cases, such as congenital hypothyroidism, so for example, iodine deficiency during pregnancy, that this can lead to detrimental health effects in children and also adults, which are irreversible. For example, the shunted growth and also mental retardation. But we also know that just the normal levels of, for example, thyroid hormone are crucial for brain development. This is shown in this figure where we look at the paternal thyroid hormone during pregnancy and then the IQ of the children between 6 and 8 years old. And you can see that there is this optimal concentration of thyroid hormone that makes the brain develop optimally, so to say. And in this regard, it is worrying that we have this exposure to chemicals, which many of them are actually endocrine disrupting chemicals, so chemicals that can disturb the hormonal signaling. And here are examples what you can find in plastics, thousands of chemicals, as Paulina already mentioned. And you see here some examples: phthalates, bisphenol A, bisphenols, the perfluorinated compounds, flame retardants, and parabens. And all of them are known or suspected endocrine disruptors. This is a busy figure, but this is describing these key characteristics of endocrine disruptors. For example, here they can bind to hormone receptors and activate the receptors in the wrong context, or also as antagonists inactivate them, or they can, for example, affect the hormone transport. So, for example, these flame retardants that are found in plastics. So we are, as Paulina already said, the link between exposure to these chemicals and health, in this case children's health, has been studied for a long time. Here, this is taken from a very recent review article from colleagues of ours, where you can see what the exposure to these chemicals have been associated and affecting fetal and childhood growth, the brain development, and also metabolic outcomes such as childhood obesity, diabetes, cardiovascular risks later in life, and of course the reproductive health, which we have already heard a lot about. So in the next few slides, I will give you a couple of examples from research we're doing in Sweden, and I'm lucky to collaborate with researchers at Karlstad University, in particular Carl Gustav Bornehag, and he is the PI for a mother-child cohort, a SELMA study, where they recruited a long time ago now a number of pregnant women and measured endocrine disrupting chemicals in their blood and urine, and they're following up the kids. They're now around 15, 16 years old, and since birth they have followed them up in terms of growth, in terms of brain development, reproductive health, and so on. And I will show you now a couple of examples focused on brain development. So the first one is the association between the endocrine disruptive chemicals, which were measured in the SELMA women, and IQ in 7-year-old kids. And what you see here is basically a busy figure, but these are the chemicals that were measured. So plasticizers, phenols, perfluorinated compounds, and also some pesticide metabolites. And here this was basically an analysis where everything above this threshold is associated with lower IQ in the kids. And you can see that not all of these chemicals were associated, but some. And the one which sticks out here is bisphenol F. You can see it here better in the single compound analysis. So the higher the concentration, the lower the IQ, in particular in boys. And bisphenol F, you might know that, is used as a substitute for bisphenol A in products that are so-called BPA-free. We call that regrettable substitution. And this is, of course, also a problem when some chemicals are phased out, but not the whole group is regulated, and the industry, the producers can just exchange, in this case, bisphenol A to bisphenol F, which seems to, at least in our data, do more harm than BPA itself. Another example here is the association with behavioral difficulties in the same setup and the same kind of graph. You can see that it's different chemicals that are associated with this. And what is also very interesting is that this is only true for girls. So in the boys, there were no associations between EDC exposure and behavioral difficulties. So basically what we find in this SELMA study, which really is confirmed in many other studies around Europe and the world, is that prenatal exposure to EDCs is associated with sex-specific neurodevelopmental impairments in normally exposed Swedish children. So maybe I haven't emphasized that enough. So this is a normally exposed population in Sweden, not very highly exposed. And so the question is, why do we miss such effects? And you have already heard from Paulina what the problems are with today's regulation. But maybe one aspect hasn't been really discussed so much, and this is actually already implied in the figures I showed you. We are not exposed to one chemical at a time, but to a soup of chemical, a mixture of chemicals. And so we wanted to quantify this a bit better when we actually take mixtures into account. How would risk assessment then look like? And we did that in a European project called EDC Mix Risk, where we basically identified mixtures based on human data, on SELMA data, for example. And then we synthesized these mixtures and tested them in the lab to generate data to then do risk assessment on them based on the levels of concerns that we had identified in the experimental data. So this is an example where we looked at the association between EDC exposure and language delay So this is an early marker of neurodevelopmental impairment. And we identified in this study what we called the mixture N, and for neurodevelopment, which was consisting of phthalates, bisphenol A, and some perfluorinated compounds. We then synthesized this mixture and tested it in different assays. For example, we looked whether it affects thyroid hormone signaling. We used tadpoles, which had these reporter genes, which basically glows when the thyroid hormone signaling is active. And our colleagues measured then the effects of this mixture N on the thyroid hormone signaling, the 1 times concentration, which was corresponding to what was measured in the Selma women, and then higher. And you can see that already in the 10 times higher, there was a significant effect on thyroid hormone signaling in this model. And based on this and many other results we got with this mixture N, we then asked the question whether how this level of concern, or these concentrations where we got negative effects in, for example, the tadpoles, how these relate to the exposures in the Selma women. And we found that above 50% of the Selma mothers had actually levels in their blood that were of relevant mixtures that were high enough so that there is a risk that the chemicals affected their children's brain development, whereas the single compounds were all far below the regulatory limits. So existing EDC mixture exposures in the general population in Sweden impact on children's brain health at levels that are considered safe. And this is, of course, in itself worrying, but of course, EDCs are not the only thing that we're exposed to. So coming back to plastics, for example, very complex materials, as we already heard, thousands of chemicals in these mixtures, plus the quite unknown combinational effect with the fact that it's also plastic particles that we are exposed to. That's just as an example. That leads to the broader picture of the so-called exposomes. So not only chemical and physical impacts, but also the ecosystem we live in, the lifestyle we are exposed to, and of course, the social exposome, the social environment, which is so important. And I really have to say that I'm so extremely impressed that you today are sitting here and listening to this webinar, where your social environment is certainly very strenuous at the moment. And I put some research into, more the social side of exposure, and found some interesting research from, for example, colleagues of mine from the social sciences, and I'm very sorry for the bad resolution of the figure. That is all what I could find. But this is basically an article about the relationship between armed conflicts and environmental performance indicators. This is exactly what it shows for Ukraine, and it's very similar in many other regions and countries where there is war going on, that the performance was fine until the armed conflict started in this red field, where the environmental performance indicator just drops really drastically. And unfortunately, this is then really difficult to restore. Here you see that this environmental performance indicator, until it becomes to this neutral, is basically it takes over 30 years or more, depending on how big the conflict is as well. So this is just taken out of this article, and I learned by my slightly superficial social science research I did in the last few weeks that there is an expression which is called environmental peacemaking. So the environment, or how one takes care of the environment, especially after a war, is really crucial for a crucial contributor for the stability of peace. and not more conflicts. So here a citation from another article that I found: one critical component of peace building is to enhance the security of people's livelihoods while promoting sustainable resource use and better environment. So I think you're doing a fantastic job in taking care of your lives now in the short run, but as you probably realize, because you are sitting here, the investment in the environment is really something that helps also better times afterwards. So I would really, really like to thank you again for attending this, and thank you for having me here, and here just acknowledgement to my collaborators and my funders. Thank you so much.
Thank you very much, Joëlle. Дуже дякуємо, Жоель, за цей виступ. Особливо подяка, що мова була не лише про ендокринні руйнівники.
Thank you, Joëlle, for this great presentation, wonderful presentation. I'm very happy that it wasn't only about the EDC influence, but also to hear about the research that follows the life of people for 15 years. And these are very precious indicators. And thank you for environmental peacemaking. If you have any ideas, please write your ideas in the chat. I never have heard about this term. Thank you, Joëlle.